Welcome dear student to our YouTube channel. Today we will practice questions from oxidation number section. In the previous secondary classes we have learned different concepts, that means the rules. We have also practiced some questions from this section. In this class we will practice some questions or some more questions. So let's start. So first I am writing two questions for you. One question is PCl3 and the another question is NH4 plus. NH4 plus, in which I am making underlining the atoms whose oxidation number is to be calculated. So just you should write here, calculate, you write, I am not writing it, calculate the oxidation number of the underlined atoms. But if in a question the atom is not get underlined, then you should decide that the atom for which there is no rule, we always calculate oxidation number by using the atoms whose oxidation number we know. That means in this case we know the oxidation number for hydrogen and we know the oxidation number for chlorine. So we will use the oxidation number for chlorine to calculate the oxidation number of phosphorus. Similarly, we will use the oxidation number of hydrogen to calculate the oxidation number of nitrogen. You should try first. After that, I will answer for you. So if you have tried, match your answer with the question. In this case, you know that the oxidation number for chlorine is -1 as it is a group 17 element and the group 17 elements has their oxidation number -1. For 3 chlorine atoms I am multiplying 3 because we always multiply the total number of halogens, with a total number of atoms with their oxidation number. And now we will just add the oxidation number of halogen here for halogen with the unknown atom. Here unknown atom is single, so I am putting here x. That means the value will be equalized to 0. So in this case the value is equalizing with 0. That means what will happen here? Why we equalize with 0? Because the charge over the molecule is 0. Because why the charge over the molecule is 0 here? Because the plus part or the positive charge of phosphorus being neutralized by the negative charge of chlorine. So there is no charge over the molecule, because charge in a molecule are expressed at their top right side top part. So here there is no charge, so we are writing here 0. So the x value for the question will be +3. By solving the value for x, we get the oxidation number for phosphorus is +3. If you have done correct, you have clear concept on this portion. So let's move for the second one. So in this case, for nitrogen, single nitrogen I am taking x. For one nitrogen I am multiplying with x. So by adding the plus value, so here hydrogen, we know hydrogen shows two types of oxidation number, that is +1 and -1. That's why hydrogen here will show only +1 oxidation state, because hydrogen atom has +1 oxidation state in compounds along with the non-metals. But when hydrogen is present with metals, that means hydrogen when present with metal, it is called as hydride, and in hydride form hydrogen shows its -1 oxidation state for single atom. But here hydrogen atom is present with nitrogen atom, so the oxidation number for hydrogen here is +1, or for single hydrogen atom is +1. I am just multiplying 4 to express the total number of atoms present in the ionic molecule. Why it is called as ionic molecule? Because it possesses +1 charge. So the compound is ionic, and now I am multiplying the total charge of the molecule with the charge of the compound. That means here the charge over the molecule is +1. So I am multiplying the added charge with +1. That means the charge over the whole molecule. So the x value becomes x plus 4 to +1. So x value for nitrogen, because x here always expressing nitrogen, so x value here will be -3, and it is the oxidation number value for nitrogen in the compound. So match your answer with the question or with the answer I have solved for you. So let's move for another question. Now I am writing another question for you. Question number 3. K2Cr2O7. Here the underlined atom is chromium. And next the question is K2Cr O4. So here the underlined atom is also chromium. So you should try first. After that, I will give you the answer. So try first. Here we know the oxidation number for these two atoms, these two types of atoms. So the unknown atom oxidation number we can calculate from the given atoms. What I have made circle for you, that means these atoms have the specific rule for oxidation number calculation. That means here you know that if you have tried match that potassium is a group 1 element and all the group 1 elements excluding hydrogen, because hydrogen varies in some cases, so all the group 1 elements has their +1 oxidation number and 2 potassium is present, so I am just multiplying 2. So in this case for chromium we are taking x and there is 2 chromium atoms are present, so I am just multiplying 2, and we know that one oxygen atom has the oxidation number -2 and 7 oxygen is present, so I will just multiply 7 with it, and the whole charge over the molecule is 0, so we will multiply the added value with 0. That means the solving the values, we will get the value for x, that means it will -12, 7 minus 2 minus 14, it is -14 here, it is -14, it is 2x, it is 2 equalized to 0, so 2x equalized, so here 2x will be 12, because -14, 2 is -12, when goes to RHS side it becomes 12, and x value will be 6 for individual chromium atom. That means here for 2 chromium atom the total oxidation charge value is 12, and for each chromium atom oxidation number is 6. That means we always calculate, from this we can conclude, we always calculate the oxidation number for individual atom. So for this compound, moving for the compound, in this case what happened, for each potassium we will also take 1, because according to rule the potassium atom has its oxidation number, that is +1. multiplying 2 with the potassium oxidation number, that is why, because 2 potassium atoms are present, but in this case single chromium is present, so we will just take X. You can also multiply 1, but there is no need for that. So for 1 oxygen the oxidation number value is -2, and for 4 oxygen the oxidation number value, just I will multiplying 4, and the charge value will be here also equal to 0, because the charge over the molecule is also 0, or neutral compound, it is a neutral compound. So the X value becomes 2 plus of X minus 8 equals to 0. So X will be 6. So you can mark that in this compound also chromium exists in +6 oxidation number. In this compound also chromium exists in +6 oxidation number. If you have done correct, you should mention it in the comment section. So first check your answer. After that we will go for another 2 questions. Now I am wiping this portion and writing 2 more questions for you. So the next question is, it is the 5th question. Here is Fe2O3, I am underlining Fe or iron, and the another question is FeCN6 3 minus square bracket express some different compound, that means coordination compound. There is no need for such complex concept in here. We will only deal with the charge value of cyanide only. So you know that from the ion section, cyanide atom or cyanide molecule, not atom, cyanide molecule has its oxidation number, that is -1. So I have told the charge value of cyanide is -1. So you should try for the question and also for the question. It is one type of complex question. We will go in coming classes more complex question which will be used in your second year section, that means coordination chemistry chapter. So you should solve easy question along with the some top level question. You should try first. So if you have tried, you know that here for one atom we take X, and for 2 iron we will take 2X, and oxygen atom has its oxidation number -2, and for 3 oxygen we will just multiply 3 and we will equalize with the charge value of the oxygen molecule, that means 0. So the X value 2X will be 6, X will be 3, that means +3 will be the oxidation number for iron in this compound. If you have done correct, comment in the comment section. So moving for the next question, here for 1 iron I am taking X, you can also multiply 1 here. So for cyanide I have told you have a great idea on the ionic concept. So for cyanide the oxidation number value is -1, and for 6 cyanide molecule you will multiply 6 and will equalize the charge value, that means -3. So the X value will be, what will be the X value? X value will be 3 for iron. So in this way we can solve different question coming from the oxidation number. If you have understand this concept, comment in the comment section. If you like the video, subscribe our channel, share the channel with your friends. Thank you.